Thanks a lot for being here today to talk about training data and model accuracy. So as said, I'm the CTO of Kili Technology, and at Kili, we develop and we provide a platform to help our clients to better build and manage training data for machine learning. And so what I want to do with you today is to share some ideas that I've collected over the past few years, and that I think could have a massive impact in terms of how we build and deploy AI in the coming years. Something we all agree on today is that there is a massive difference between traditional software on one side and AI on the other side. Software is made of code. AI is made of both code and data. And in fact, AI is made of three things: code, computing power, and data. Code, it's really easy. You can find all what you want, state-of-the-art models on GitHub. Computing power, same story. You can find, thanks to the cloud, all the GPU that you want easily. Training data, it could be the same story. Thanks to the digital revolution, almost all the information of the world is stored digitally, so meaning readable by computers. But what works today in terms of AI is supervised learning. And so what it means is that you not only need data to train your models, but you need to have structured data. So data structured as examples. A bit like when, a few years ago, on Facebook, you were tagging your friends. On one side, you have the image, and on the other side, you have the information, so the face tagged with the bounding box on the image. And to structure the data, we need to annotate it. And this is complicated. It takes a lot of time, it's human power, and it's very costly. And this is the reason why, today, data is really the new bottleneck of AI. For instance, on this project, where we had to recognize patterns in cells, on one side, we used a data scientist, and it took him only 2 days to benchmark state-of-the-art algorithms, and the impact of his fine-tuning was about 1% of performance. And on the other side, we had a team of radiologists labeling the data, and their work was in a matter of months, and the impact of their work was about 10% in performance. And so what it means is that today, data is really what makes or breaks your AI project. And this is the reason why data management, training data management, data-centric AI is becoming a really exciting and really active research topic. So what I want to do next with you is to share 2 challenges in this topic and explain you how we tackle them at Kili. The first challenge is having consistent data. To illustrate my speech, I will take a toy example about kitesurf detection. But what I'm going to say works for any kind of use cases. So from rust detection on ships, to target detection for defense and surveillance, to retail use cases, cancer detection, NLP, email classification, chatbot improvement, complex form processing, and contract processing. But let's go back to my kitesurfers. So let's say I want to build an AI to detect kitesurfers. I will go to the beach with my camera. I will take a few hundred pictures, and then I will go back home and ask a few friends to help me tag the data. The first labeler will give this kind of output, the second one, this kind of output, and the third one, this kind of output. All of them are right. All of those outputs are OK. But there is a major issue for me. They are inconsistent. They are not consistent. And why is it an issue? Because it's going to impact the performance of my model. This inconsistency is going to impact the performance of my model. What we estimate is that a 10% decrease in annotation in labels accuracy impacts from 2 to 5% the accuracy of the model. So it's major. My question next is, how can we tackle this? And the issue also is that this kind of inconsistency can be of different kind. It can be in terms of naming. So what is a kite surfer? Is it the person, or is it the person plus the kite? It can be in terms of position of the bounding box. It can be in terms of size of the bounding box, and so on and so forth. So how to tackle them? The first idea is to use consensus. The idea behind consensus is very simple. Instead of annotating every image once, you annotate it twice or 3 times by different people, and then you compare. You compute an agreement score between the different outputs of the annotators, and then you are able to filter your images based on this agreement score. You only keep the images with 100% agreement, 100% consensus, and you train your model on this. And what we observe is that very often, given the sensitivity of models to the consistency of the annotation, it's much better to annotate less images with consensus than more images without consensus. The second idea is to use instructions. Once I've annotated my data with the consensus, I can filter the images. I can keep and zoom in the images with the low consensus and review them. And for each of them, I can choose what is, according to me, the right annotation between the different annotations that were given by my different labelers. And then I can document this decision on a document named the instructions, and I share them with the annotators. And the idea is that doing this, you align them so that they have the very same definition of the annotation. And I do this iteratively at the beginning of the project. The third idea is to split tasks. Maybe some of you know this paper from the University of Stanford named the Solon paper. In this paper, they want to annotate this pretty complex task of summarizing a document. And so at the very beginning of the paper, they send the document to a crowd, and they ask them to summarize it. And they get pretty bad results. And in the second part of the document, they say, OK, we will split this task into more simple ones. The first subtask being, OK, for this paragraph, please say if it's possible to summarize it or not. Second subtask is, for the paragraphs that are said to be summarizable, please summarize them. And the third task, for those paragraphs that have been summarized, please verify that the meaning has not changed and that the paragraph is shorter. And so doing this, they get much better results for a very decent price. And so the idea behind, and my advice, is split your annotation tasks, so divide to conquer. Split your annotation tasks into simple ones to handle the quality. The second challenge that I want to share with you is to have complete data. To have a model to build a model that perform well on different scenarios, I will try to cover those scenarios. So people doing kitesurf as usual, people jumping, people doing kitesurf in the sun, people saying hello, falling down, and even doing kitesurf overnight. And so what it means is that I will need to build my data set, my training set, as a collection of scenarios that needs to be covered by my model in production. So how to do this? The first key, the first idea is to slice data. What it means is I need to be able to identify within my data set some slices or some strata of data where my model is systematically underperforming. And the way to do it with Kili is very simple. Once you have annotated your data, you export your annotations, you train a model, and you re-import the predictions in the platform. And then you are able to project the performance of your model on different dimensions of your dataset, such as the sharpness of the images or the brightness of the images. And then looking at the performance as a function of, for instance, the brightness of the images, you will be able to see that for dark images, the model is systematically underperforming. You will be able to zoom in and see that, in fact, all those images were taken during the night. And then you will face a decision, which is, on one side, you can just delete this scenario, say my model doesn't need to perform and to cover doing kitesurf overnight. And so you just delete the data. Or you need to reinforce your model on this scenario, and so to label more data. The second key is to iterate fast. So to build models in this data-centric way, you need to constantly iterate between collecting the data, annotating it, slicing it, and training your model. And whereas for software development, iterating is really fast, and one key success factor of the software industry those last few years is that basically you can iterate very fast in a matter of minutes between developing a new feature and testing it. This is not the same today. This was not the same today for machine learning. It takes usually hours, days, sometimes even weeks between two iterations in machine learning. And so the idea with Kili is to help you with machine learning at every step of this process. And so, for instance, for annotation, instead of drawing the border manually around an object, you just have to click on it, and the border is generated automatically with interactive segmentation. The third key is to update the data. Once your model is in production, the story is not finished. Why? Because data is changing all the time. The shape of the kitesurf has changed. Logos are changing. Everything is changing. And so the way to tackle this is to sample the predictions of your model running in production, to re-import them in a platform, such as Kili, and then to annotate the data. Then you are able to benchmark the prediction of your model against the ground truth you just created through annotation. And then you will be able to study the evolution of the performance of your model and to detect any drift of performance. So to conclude, my 2 cents on and my few takeaways on developing models in a data-centric AI way is that very often, on many use cases, it provides much more value to iterate on data than on the model. When you work on data, when you annotate, you have to pay attention to data consistency. because it impacts a lot the performance of the models. When building your training set, you need to think about it as a collection of scenarios that needs to be covered by your model, not as a monolith. And last but not least, you need to iterate fast. And to be able to iterate fast, leverage a platform. There are some of them. Thanks a lot.